Right, good evening, everyone. Right, today we want to continue with our discussion on loci, in particular mechanisms. All right, but we want to look at a revision question from the past, that is 2018. So basically we are looking at application of the concept that we have started so far. Like I said, revision task. Let's hope you are going to follow in terms of all the procedures and processes that we are going to undertake in order this particular question. Right, the content in terms of today's lesson, we are looking at mechanisms. Right, like I said, it's a revision task from 2018, November 2018. Right, we want to look at the construction and application part of it. As always, right, we don't forget these important ways in terms of our approach to technical and practical subjects. I hear and I forget, I see and I remember, I do and I understand. The thrust is to make sure that you are able to do it in order to understand. Once you have understood, definitely you should be able to apply and work on any exercise. Thank you. Right, okay, like I said, we are looking at question number. Last time we're looking at the chem, right, which is the question at the top here. We did go through this question. Today is on this one. All right, the task is as follows. A schematic drawing of a mechanism OA. We have got OA as our crank. Remember, the moment you hear the word crank, you know motion which is in the form of a circle. Sliding rod AB, we have got A, B, right? If it is sliding, which means it's going to move, right, on a particular surface. This particular surface, it will be FG, okay? Right, so if I were to move this one slightly, F and G, so that is the sliding, so it would move to and fro according to the movement of the crank. Then rod CD, we have got C and D, right? Rod C to D, which would pass through point E. Right, so we have got C to D, which should pass through point E, like horizontal groove FG, I've already talked about that. Then the swivel guide E, right, this would guide the movement of C to D, which is that point E. The position of center point O on the drawing paper, right, we have got that position, right, that. So what is it that we are expected to do? The positions of center point O, the swivel guide E, and the groove FG are fixed. Right, when anything in terms of mechanism is said to be fixed, which means it does not move, right, you would find that we cannot remove it from that particular point. So you have got point O, it's fixed there, it's not going to move. We have got point E, it's fixed there, it's not going to move. We have got the groove FG, it's fixed there, it's not going to move away. Sliding AB, sliding rod AB, we have got A, B, is pin jointed to crank OA. When something is pin jointed, right, it allows movement, but at the same time, you cannot separate the point. Just imagine you are looking at your arm, right, which is pin jointed at your shoulders, right? The arm is free to move about, but we cannot take that arm away from the shoulder. So that is one good typical example of the pin joint. You have got your leg, you have got these other members of your body which are free to move about, but they cannot move away from that connection. So we refer to those ones as pin joints. Right, rod CD is pin jointed to A, B, and C. Right, so CD is joined there, but what would happen is that this would be able to move or create its own motion with regards to the movement of OA. Right, so as OA rotates, all right, are we given the direction? We are not given the specific direction. All right, so we might have to create our own direction. But okay. The motion at the bottom is given as crank OA rotates in a clockwise direction. Okay, clockwise, like in a clockwise direction, point B of the sliding rod AB reciprocates. Reciprocate, it means it goes from, right, creating a path, but this path is in form of a straight line. So there is movement which you will be able to see B, which would go forward and backwards like that, but it will be in form of a straight line. So basically it will assume the line FG as well. Right, then we are also given that CD to 90 millimeters. So from here to there, it's 90 millimeters. Right, then motion swivel guide, which is this point E, right? So this trained to pass through point E. When we talk about constraint, we are talking about being forced to E. Right. Draw to scale 1:1 the given schematic drawing of trace the loci generated by point C, which is point C here, and by point D, one complete rotation of crank OA. Right. So now what we want to do, right, is to go to the point that has been given. Right. Let's draw a faint horizontal line from here, like that. Then a faint vertical line. Yes. But the diameter or the radius or OA is 75. So we are going to say radius is equal to 75 to 2, which would give us 37.5. Right, so we are going to measure. Right, so that's 30, 35, 37.5. That's our. You take your compass. Then you describe. There you go. Right, so this is point O, and this one would be point A. So I'm going to label this one A like that. Right, now we need point B. Right, if we look at this, we have got our point B here, which is this point, the location of point A, right? But what we are told that this FG, that's what we need to first establish, which is the is going to move. It's located 30 millimeters from the center line. So what we need to do is to measure, right? Like that. So that's where we are going to locate FG, right? We can do that. But first of all, let us first 105 in terms of the distance from A to point B there. Here, like this. The correct scale. That's 100, 105. Note that is the point that we require. Measure and then open your canvas to that respective distance, like that. Point A, right? And you describe an arc. It's about basically the same point. So the distance from here to there is 105. If you stand at point A, right, like that, you describe point B. So we are going to say this is our point B there. Right. You can connect point A to point B. There you go. And you have A and A to B. Right, this B is located 30 millimeters from the center line. We shall define the center line. Right, like that. So we have got O, A, and A to B, okay? Then we need point C. Point C is 53 millimeters from point B, right? So and mark a point like that. And point C like that. Right. The next thing that we want, right, is to look E, which is, if we look from here, 25 millimeters from the center line and 83 millimeters from here. So we can measure 83 millimeters. Take this one down. Yes. Then we measure from here to the 27. Right, that's our point E. Right. Then we have got, in terms of our construction, we can join from point C. Remember, you need to copy everything properly, right? We have got here, that's like that. Right, then we measure CD, right? From millimeters. We are given that information, that's 90 millimeters, right? You measure from there. That's our point D. Right, we label that, okay? So we have got C, D, which is E, like that. We can outline this, right? Let's outline CD. There you go. Right. So in terms of our infrastructure, right, we have got point O, which is there. We have got point A and B, A, B, which is 105, which is the distance from here to there, which is exactly 105. Then we've got C, D, right, which is 90, but this E is located, right, from here to there, that's 27, from here to there, that's 83. Right, okay. So we are done with the information. Remember, we need to find the locus C. We also need to find the locus of point D for one complete revolution or 10 of OA. Now, at this point, we can show the center lines. It's critical. Remember, you copy everything except for the dimensions. It goes up slightly, right, just to define everything. And we have got this one is our FG. We have got this is G, this one is F. Okay, so FG, that's the groove. Right, once you have done this, right, in terms of now, what you need to do, the thing, you divide the circle into 12 equal parts. We are also told that it is moving in a clockwise direction here. Right, like that. Right, so that is the movement in terms of, right, in terms of crank OA. Let me just extend this. So that all the divisions are cut. Right, anywhere else, that's fine. But make sure that all the divisions are cut. So you have got this one, that's A1, A2, A3, this is A5, A6. There you go. Right. So you are going the movement in terms of intervals. The intervals are these divisions that we have created. So you are going to move point A to there, see where point B would be, move point A from here to there and see where point B would be, right, by find the new position of point B, right? Once we have now look for the new position of point C as well. Right, so let's start with regards to this. Right, so distance AB, that's AB, take this particular distance, you stand at the new position, right, and strike an arc like that. That would be B1. 2, and strike an arc, and that will be B2. What you do, that will be B3. B4. B5. 6. B8, right, the next one, B9, B10, B11, right, so you have got those points, right, so you now connect A1, 1, then A2 to B2, A3 to B3, like that. So let's do that. They shouldn't be mixed up in terms of these points, right, like that. Then we go to B2. This is B4 to A4. Remember, point B is always located on the groove FG. When you are not sure that you go back, just check, verify. It's important. There you go. You have got your answer. Then you move on. like that. Once you have done that, you now take A to C, right, which is located in between A, this one like that. You go to the new position, point A1, right? You describe. So what you have there is point C1. You go to 2. Then you have at this point C2. Cut this one. You have what C. Then C4. C5. So you are busy locating the points. You go to number 6. You cut line from A6 to B6. Then you have got C. You do the same for 7. C7. But remember, I'm out labeling these points so that you are able to see clearly. All right. But in an exam, in a test, you may not be able to show these labels. But as you would see, they are critical in terms of coordinating where you are coming from and where you line, C line, C10, then C11. Back to the starting position, which is point C. Right. We join these points. You may want to just check and see whether there is a pattern that has been created. Right. Connect. Just check. Like this. There you go. Now, once you have gotten this, you can even outline. But when you outline, you make sure in terms of your quality of a curve, right, something like that. Then you can label nicely. Right. That is, you can create a guideline. Locus. point C, right? Locus point C, we are basically saying this is the path which is followed by point C as the crank OA rotates in a clockwise direction. So that is the path. Remember, the locus basically it means a path. When it is in plural form, it's loci, or some would call it loci. It depends on how you want to relate to that. So we have got the locus of point C. Now, once you have gotten the locus of point C, this would enable you now to get the locus of point D. Remember, point C is located on AB, okay? Right, so we have got a series of AB, 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 right? So at each and every point where we have got point C, point C, point C, point C, we are going to draw lines through point E, which is our guide, okay? Right, so let's start. Right, so from here, like that, we draw a line. Just bring this one up a little bit. But we draw a line like that. Via point E, we go to C2. Again, via point E. Then we go to point C3. We go to point, right. One thing that I just want to make sure that you are aware of, if you create, but they would end up confusing you, okay? Right, so we have got 3 lines at this point, so we can take the distance from D, right, to C, which is the same as C to D. Right, stand at point C1, like this, and describe an arc. Right, now that is our D1. So you can label, this is your D, like that. Then you stand at point C2, right, which will, right, that is our D2. Then you stand at point C3, mark like that. This would give us D3. Right. You can carry on. Just make sure that you at least mark 3 lines or draw 3 lines. Then you mark the respective ends. Right. This 4. Then we now have got 5. Then we have got 6. I think we can accommodate. Let's deal with this. Right, there is number 4. Right, you know, that's D4. We go to number 5, which is here, you know, it's D5. You go to number 6. But remember the distance is still 90 from here to there. But you go to number 6, you know, that's D6. Right. Once you've done that, you now move on to the next set of lines, which is 7, 8, and 9. Right. 7 is here, 8 is there, 9 is there. Sorry about that. Through point E. So from here, like that, okay. You'll be able to see. Then you have got 8, Right, you can just label that. And then you have got 9. You can just label here. Right, this is just to make sure you are guided to 7, which is the one at the top. 7, then let me go to 8, the one closer to, which is this point, then let me label it D8, then 9, D9, right? Now I'm left with 10, 11, and back to D, which is our point 0. I go back via point E. Like that. But I think this one is clear. Right, I've got my 4, 2, 11. That's my 11, which is closer to 0.5. Right, go to 10. 10 is here. Then up that. That's D10. I go to 0.11. Which is here. That's D11. Come back to 0, which is our initial point. Right, so we can connect from here. Sorry. And we can also do the same this side. So that is the path which is followed by point D, right? As crank OA completes 1 revolution or 1 turn. So the next thing that we would want to do is to outline this. Right, let's hope you are following the steps and the procedures that we are unfolding right now, right? So that you'll be able to do it on your own, right, as application. Remember, the thrust is on you having to do it independently, right, without anyone assisting you. Right, I'm going to outline now. We do the same this side. Make sure your eyes have got a dual function. They see where you are going, but at the same time, they also see where you are coming from, so that your curve that you are going to draw would be visible and clear. Right, there you go. Right, so that is the locus of point D. Remember the steps to take. All right, if you are given, right, the schematic diagram, right, just to reiterate on that one, right, schematic, it means basically it's a line drawing, representing a system. So you have got the system of the crank, which is represented by line OA, right? If it says it's a crank, what it means basically is going to rotate, and its point A is going to move about point O, right? By doing so, it creates a path, okay? Right, so generally, this is what we refer to as the locus of point A, which is already there. Now, you put everything in position in terms of the sizes that are given. Make sure you check on that in terms of the sizes. It's critical. Then you also define the rotation in terms of the direction, right? Once you have done that, now you create points from the movement in terms of intervals of point A, which is the principal actor, right, to the guide, which is FG, right, or the groove, which is FG, but the distance from A to B does not change. So whether you are now here at point A1 or A2 or A3, the distance from A to B does not change. So you end up standing here and striking arcs, right, at point 1, 2, 3, 4, 5, and so forth, up until you get the other end of point B, right? Once you have done that, you now take the distance from A to C, right? You stand at the new position of point A, describe an arc to locate point C on now the alternative positions of AB, right? So you have got A1 to C1, A2 to C2, A3 to C3, and A4 to C4, like that. Once you have created this path, which is your locus of point C, then you use the same points that you have created, right, to locate the points, the new positions of point D by drawing lines through the guide. Remember, if it is said to be constrained to pass through point E, so it means that it is forced to pass through point P all the time. Then from there, you identify the points or locate the points, join the points, and outline. Then you end up having a locus. So we can also write here locus point D. Right. Like I said, this is a typical exam question. We took it from the November 2018 paper, right? And it was worth 25 marks out of 36 marks. Right. You'll find that the first part, which was for the chem 11 plus 25, you would get 36. So it's easy to pass these exams, right, if you know what to do and how to go about it. So when we meet again tomorrow, we are going to look at another application task with regards to link mechanism, again from the past exam paper, so that we have got this understanding on our fingertips. I hope you enjoyed this lesson, and good night.